Hello everyone, today in this video we'll be discussing the module 5 of OS which is related to file system. Okay, so there are three topics here which we'll be discussing in depth, and make sure you watch this video till the end. And before starting, please do like and subscribe, that helps me make more videos like this. So without wasting more time, let's get started. The first one is file and its concepts. Okay, so what is the main things, the key points in file and concepts that you need to know from the exam point of view? First, what is a file? File is a named collection of related information. Okay, what all information you have, that all will be stored in a similar place, and the information is related, that is stored on a secondary storage. Okay, that is called as a file. And the attributes of the file include the name of the file, the identifier, type of the file, location where it is stored, the size of the file, who can access that, it's called protection, time, date, and user identification, which user is trying to access that. All are the file attributes. This is very important question from exam point of view. Next is file operations, again very important. What are the operations you can perform in the file? Create a file, write on the file, read the file, and reposition a file means change the location of it, delete the file, and truncate a file. Okay, what are the different types of files? Exe, executable files like the apps which you use. Object file, which is the machine code and it is not linked, that is called object file. The C is the C code, that type of file, or java.java.python and so on. Bat is the batch file which is used to execute the PowerShell scripts. TXT file, document file. PDF means it is the printable document format or portable document format, this is used for printing. Library file, zip file which is in archive. MP3, MP4, JPG, these are all the multimedia type of files. Okay, so these are the different types of files. A file can be accessed by the following methods. It can be accessed sequentially method, wherein you access one file, next file, next file, next file in a sequential order. Direct file means you know where it is stored and that location directly you will access, that is direct access. Index means there will be a separate index which is kept, which will be showing which file is stored where, and using that index you will be accessing. It can have multi-level index also, this will further have some indexes, and in that also you can have further indexes and so on until you reach the final file. Okay, so files are stored on random access storage devices including hard disk, optical disk, and memory based disk. Okay, so they are stored in these types of disks, and the structure way, how it is stored is the directory will be present and under which some files will be there, another directory, another some files. So like that partitions will be there. Okay, it will not be stored as single storage, different partitions will be there. And the following operations can be performed on directories. Same, search for a file, create file, delete file, list all the files in the directory, rename the file, and traverse the file system means go through all the files in the directory. And there are five implementations of directory. The first one is single level directory. You can have here the directories and the files corresponding present in a single level. Two level directory means you'll be having a directory here under which another directory can be present, under which the files are present. So if there are two levels of directory, it's called two level directory. If it is more than two, it is called tree structured directories, which can have multiple level of directories. Acyclic graph directories will have different connections to each other's directory and the files, but it is not having any cycle. Okay, the next one is the general graph directory, wherein it is same as acyclic one, but there will be a cycle. See, from book to AVI, AVI to book, there is a cycle present here. So if a cycle comes, it is called as general graph. If a cycle does not come, it is called as acyclic graph directory. Okay, next is the file mounting, which means the opening of file. The process in which you open the file, it is called as mounting. Now suppose that you have different levels of files. Okay, in the first directory you have some folders in, and if you open that, you will get some folders here, and in each folder you will be having some other folders as well as files. So whenever you open one folder, you will be getting an access to the entire files and folders present inside that. That is what is called this. Users will be this and this, Bill and Fred. Now Bill, when the user Bill opens the directory, they will be getting access to all the files present and all the folders present inside that. So that is denoted by a rectangle here. It consists of all the files and folders, and if it is having another directory, that will also be included here. Okay, like that it is. That is called as file mounting. File sharing can be done in two ways. System can allow access to access all the files by default, or system may require a user to specifically grant access. Those are the two types of file sharing. Most of the system use the concept of file and group. Okay, you can have a file or you can have a group of files and folders present within them. Remote file systems are also used when manual transfer, automatic distributed file system, and World Wide Web can be used, wherein you'll be accessing the files not present in your system but some other systems. For that, we'll be using the client server model. Okay, to transfer the file between client and the server, which are all not usually present in the same location. And to ensure protection of files, access control method are used. Okay, access control means who can access and who cannot access, and the access can be given for write, read, execute, append, delete, and list all the files. So you can give the particular access to perform any of these operations or all of them. Okay, there are three levels of control: owner, if a file is an owner, the owner can only access, and the group means in that group how many people are there, they can access. Universe means all of them can access. Other protection method includes password. To protect the file, if you want to protect it from anyone, you can use password. Those who know the password, they can only access. File system uses layered approach. What do you mean by layer? There are different layers here. First is application programs, and that will be linked with logical file system, or file organization, basic, IO control, and devices. The last level is the devices which we use. Okay, so these are the different layers present inside the file control. And you have different blocks of files. Okay, FCP means file control block, which will store the information about the file like the metadata and all. Boot control block. Block means it's a set of data wherein the information will be written to perform a specific action. Like for example, in boot control block, the information for booting and rebooting, restarting and shutting down, those information will be present. Volume control block will be having the information to handle large data, to organize it. A directory structure will have the list of all directories. A per file will have the extra details about the information of the file. Okay, more details of the file can be found inside the per file block. Okay, and you can use the virtual file systems if you want to separate file system from their implementations. Okay, so this is the diagram, very important. Here we'll be having the file system interface, which will be linked with VFS interface, virtual file system, and the virtual file system will be given access to other local file systems. Okay, so what does virtual file system do? It will not give direct access to the file system interface. It will provide a logical, I mean the imaginary layer in between, that will make the tasks more simpler to understand. Okay, that is the use of VFS. Directory can be used, can be implemented via direct indexing or hash functions. Okay, directory means where it should be stored, all the files. If it is in a directory, where the directory should be stored, directory 1, directory 2, that can be decided via direct indexing. It will be stored as direct indexes, one after the other, or using hash functions. What is the answer we get from the hash, that answer will be used as a pointer to point the directory. Okay, and there are three methods that exist for allocating disk space. The first is contiguous allocation, wherein all the memory which you want, that will be allocated continuously, and another one will be having in a separate place continuously. That kind of allocation is contiguous allocation. Linked allocation means it can have different places but all will be linked so that it looks like it is a continuous block. Index allocation will be having the allocations but with an index as well. There will be an index present which will point where what is stored. Okay, next is free space management. After you delete some data, you'll be having a space created that is called as free space, and it can be reused. How do you manage that? You can manage it using the following methods. The first one is bit vector. 1 is free, 0 is allocated. So if you have a vector like this, you'll be able to understand which are all free. See, this is free, this is free, this is free. So we use bit vector to make the computer understand that. Linked list can be used. List of all the free blocks is maintained as a list. Group can be used. Group of free blocks from in a symbol, same place. Count of contiguous free blocks from the where it is kept. Here we will be having the count of how many free blocks are present after a particular block. Suppose this is the block, I have 3, means 3 blocks after this are free. So I just have to store this information and 3, so that I'll get to know that 3 blocks are free after this. Space maps can also be used in some advanced systems. Manageable chunks of blocks are mapped. Okay, moving to the next topic, which is secondary storage systems. Now let's understand how the things are stored in the memory and how do we access them. Some algorithms also there. First, we understand what is a magnetic disk. As you can see here, there is a stick here. Okay, and this stick has some arms. Okay, this stick is called arm assembly, and these are all called as arms. Okay, now these arms are connected with a platter here. This is called as a platter, which will be like a CD, and they will be having sectors. These are all called as sectors. This is one sector, this is another sector. The circle things inside one, that is called sector, and the space between them, this one, this one, this one, these are called tracks. Okay, so track, sector, platter, this is the arm, and this is the spindle in between which is having this one. And whenever we want some data, this one will be staying in the same place, this one will rotate until that particular data comes from the track to this point, and that will be read. Like that magnetic disk works. Okay, so some important concepts here. What is seek time? Time required to move the disk to the required track. Which track you want? Suppose that I want this track, so it will be moved here until this point, overlies with this one, so that we'll be able to read. That time is called as seek time. Rotational latency is the time taken for disk to rotate, so that required sector comes under the read write head. So this is about the track. The first one, seek time, is about the particular track, but sector means moving this one so that it comes, the whole circle comes on the top of this. Okay, it is not required that the track comes, but only what is required is the sector, whole sector. If it is coming here, that is the time which is taken, and that delay or the latency is called as rotational latency. Random access time is the summation of seek time and rotational delay. Disk bandwidth is total bytes transferred divided by transfer time between the first request and the complete of transfer. Transfer rate, how much data flow happened between drive and computer. Okay, next we have magnetic tapes. It can store larger quantities of data than the previous one, magnetic disk. Time required to access data is larger because search is sequential, one after the other it is set. If it is not this, next, directly we cannot access like in the magnetic disk how we used to access. And here it is having large data, so the time required is more. Okay, so there are two types of magnetic disk. First one is CLV, second is CAV. CLV means constant linear velocity, which means where farther track is from the center, the greater is its length. Okay, suppose that I want to access this one, I have to traverse this much from here till the middle. When I reach that much path I have to traverse. Okay, the farther it is from the center, the more it is its length. CAV is constant angular velocity. Here each one is a part here. Okay, so this one is uniform here, and this type of arrangement is called constant angular velocity. Okay, and here the number of sectors are same in each track. Okay, data rate is also constant. Disk attachment means we are accessing the data from a computer. Okay, there are two ways in which computer can access the data: host attached storage and remote host in a distributed file system. Host attached storage means you can have the data or the secondary storage within a part of the computer, that is also host. If you have a separate storage and you connect it via the computer, that is also called as host attached storage. But if that data is using a network and accessing it, that is called as remote host in a distributed file system. This includes SAN also, storage area networks, and NAS also, network attached storage. Okay, some scheduling algorithms, that means if I want to access some data, how much time it takes. The first one is FCFS, first come first serve. Okay, now see, all these algorithms are related to a disk here. Just imagine one disk is present here and there are different tracks present here. Okay, and each track is divided into different parts. Now suppose I want this part, but my read write head is here. So what happens, it should rotate and come make this come here, right? So how much time it takes to do that? First come first serve. First I want this track, then this track, then this track, then this, then this. So first it will come here, then it will go here, then it will go here, then here, and so on. In that order if it goes, that is called as FEFS. SSTF, shortest seek time first. So given all the things which I have to access, it will see which is first. It will take least time, second least time, third least time. In that order if it access, it is called as SSTF. Scan means it will rotate the whole sector from end to end, and again it will go back. Okay, like that, again it will come, again it will go back, like that. That is called as scan. Elevator, see elevator how it goes from down to up, again up to down, right? So that is called as scan. C scan means circular scan, means here in the previous one it comes here and again it goes back like this, but in circular scan it will not go back, but it will continue like this, again it will continue like that. Okay, and in between wherever the things come, it will solve it. Okay, look means we are going to that specific spot and then next specific spot and then specific spot until I reach the end, and again I will go back in that order. Okay, here we are not just simply going, we are looking for that particular thing. See look means circular look. We'll suppose these are the things, I'll go here like this look, and again I'll continue from here, I'll not go back here. Okay, that difference comes. Okay, so that is C look. Now since different algorithms are given here, which one is the best algorithm which we need to select? That depends upon the situation. SSTF is commonly used, and it increases the performance over FCFS. Okay, given SSTF, FCFS, which one you will select? SSTF. Scan and C scan is better for heavy load on disk. If there is a heavy load on disk, you will use which one? Scan and C scan. They have less starvation problem. Starvation problem means one of them is not getting a chance, but that will not happen in scan and C scan. Why? Because it will rotate and it will ensure that all of them are getting chance, like that. SSTF and look are a reasonable choice for default algorithm. Okay, so most preferred one is SSTF, shortest seek time first, and the other ones also depending upon the situation can become more better than SSTF. Okay. Disk management means the process of dividing the disk into sectors and filling the disk with a special data structure called as formatting. Okay, and by organizing it in a particular format, we'll be easily able to manage the data in the disk. Okay, when computer is booted and switched on again, means shut down and restarted, it should have some data regarding what needs to be done. That data is provided by bootstrap program, and the program is stored in a boot block. Okay, so what is a boot block? The place where the restarting computer data is stored. Okay, and bad blocks are the ones which can change the whole disk. Means if there is a wrong data here, because of the wrong data, the whole actual data can be changed. That is called as bad block. Swapping space management. What do you mean by swapping space? Swapping means when physical memory reaches a critical point in low storage and processes are moved from memory to swap space to free the available memory. If there is a memory space here which is full and it is an empty space here, and the requirement is to run a process, but since the memory is full, we'll swap it with the free space and take the free space here and run this. That is called as swap space management. Okay. Last topic is protection. Okay, so what do you mean by protection? It is a mechanism of controlling the access of programs, processes, or users to the resources defined by a computer system. So who can access what resources? That is called as protection. Okay, and to implement protection, the standard format used is domain structure. Okay, so this is the domain structure which is used here. The object name will be there and the write sets will be there. Okay, for example, object 3 can access read and write, and object 2 can access execute and read. That forms one domain. Okay, like that we'll be forming different domains. Okay, and access matrix provides the data regarding which domains have what access to which files. Okay, so here in this column you can see there are domains given, and here you can see the files given. Which domain can perform what operation on which file, that whole information is provided by access matrix. Okay, also we can have what domain can control which domain. Okay, that will be an extension of this same matrix, but that is also possible. They will be having the options to delete a particular domain or edit a particular domain or switch from one domain to other domain. That accesses are also given. Okay. The following are the different methods to implement access matrix. Okay, so that is access matrix, who can access which files and perform what operations. And the implementation includes the following. The four implementations are there. The first one is global table. When an operation is executed in a domain d1, okay, there is an operation, okay, which is needed to be performed in which domain d1 and which object o1. The following is searched in the global table. If d1 comma o1 comma write set is present, and that write includes the operation which we are going to perform, for example executing it, so the write has that execute operation present here, then only the process continues, else it stops. Okay, means if you don't have this triplet which is registered in the global table, if you don't find this one, that means that particular operation cannot be performed on the object o1 on that domain d1. Okay, access list is also used, where each column in the access matrix can be implemented as a access list. Okay, so what are the columns present here? The columns where f1, f2, f3. So f1, which domain can access what files and do what operations, that thing is present here. F1, who can access and do what, that information can be done as an access list. For example, f1, in that list it will have d1 comma read, d4 comma read write, like that. Okay, so that implementation is access list. If we use capability list of object with operations allowed on those objects, which objects what operations are allowed. Okay, that is the list which stores capability list. Lock key mechanism can be used, where each object has a lock. Okay, what has a lock? Object has a lock and domain has a key. Now operation will proceed only when the domain has an object that unlocks it with that key. Okay, and the following methods are used to revoke the access rights. Suppose we have given rights to many objects, now we want to revoke it. We can use using reacquisition, means resetting all the rights which we are granted after a particular point of time. Back pointers, we have put the pointers and take back, that means delete that pointer to that particular object, so their access will not be available anymore. Indirection means indirectly using the techniques to revoke the access by using some pointer method which will be pointing to one object which will be given to other object. So if we revoke the access for the first object, automatically the second one will also be revoked. That kind of method is called as indirection. And keys, you can use keys, you can change the value of the key so that it will be no more used to unlock. And the following are the two examples of capability based protection system. Now the first one is Hydra. What does Hydra do? Hydra is a capability based flexible system that provides fixed set of possible access rights. Okay, so these examples are related to how the protection of the capability based protection happens in the system. So what does Hydra do? It has a fixed set of possible access right, means it has a fixed set who can access what, and that only will be used. Operations on the objects are defined procedurally, and Hydra also provides right amplification, means what rights are present can be edited and modified. Whenever a user passes an object as an argument, it will not start the process, it will access the checks which are made immediately to see if that is the object is having the particular rights to access the resources present and the files and perform the operations. That check is happening immediately. So that's the first example, Hydra, which has these following features. Next one is Cambridge cap system. It is simpler and less powerful than Hydra. The standard read, write, modify those rights are provided by checking the access. This is called as data capability. If you check all these rights and then only will provide the access, if it is present, then we will call it as data capability. Another one is the capability which is software capability. This is related to making changes in the software internally. That check is made if that user is or the object is having the right to make the internal changes to the systems programs. This check is also it also increases the access protection. Okay, so these features are provided by Cambridge cap system. Okay, that's all. And if you found this video helpful, please do like and subscribe. That helps me make more videos like this. Thank you so much for watching. I'll see you in the next one.